Hey everyone, guess what? We do not have ugly swag. We have spaced out radio gear that you're going to want to wear. Why? Because no one wants to wear ugly clothing. So head on over to spacedoutradio.com and go shopping today. You'll be glad you did. And it's a great way to support our show. Once you get your gear, send us a picture of you rocking out in your SOR swag. spacedoutradio.com, shop there today, and make yourself look good.
Welcome, Spaced Out Radio special edition. Today is the day we've all been waiting for. NASA is holding a press conference in about 30 minutes here, and we'll be going live to that. 3-Eye Atlas, the high-rise images. You know, this should be either way, whatever side you stand on this. Comet, alien tech, something brand new that we're just discovering. Either way it goes, we should walk away with something exciting, right? So put your expectation. I have some expectations, and we'll actually go there in a minute, but don't be disappointed if it turns out to not be what you thought it was, right? Keep an open mind on this, because I think either way it goes, we're going to walk away from this with something very exciting, a really good image. I'm hoping of a comet, traditional comet, or a really great image of something new that we have not discovered as of yet, or a close-up image of a massive alien spacecraft. One of the three, I think, and I think we could all walk away and feel okay about whichever result we get here. But I do have some expectations, some things that I hope to see come out of this press conference. We're unsure how long it's going to be. If it's going to be a 15-minute press conference, if it's going to be an hour, we don't know. So we're going to go over a couple things here leading up to the live airing of this press conference here at the top of the hour in about 25 minutes. Let me go ahead and see who has joined us here. Just give some shout outs to who has shown up here to this live event. And it looks like we got Kitty Catty Whack out there. Hey, Kitty Catty Whack, thanks for coming in. Stargazer saying cool, appreciate you. Mel WD40. So these are the first three. So we usually give medal positions. So we'll go ahead and do that here as well. We got Kitty Catty Whack with the gold. We got Stargazer with the silver. We got Mel WD40 getting us lubed up for the show and also coming in with the bronze. So we do appreciate you guys coming on in. Candace Helfrich, appreciate you showing up. Should be an exciting an exciting stream. I'm thinking. Lil Cam 51 saying, heck yeah, appreciate you coming on in. We got T Bone saying, hi, Mr. Rob G. Thank you, T Bone, for coming on in. Appreciate you. Also, Andy Cowley, appreciate you coming on in, saying hi, Robbie G. Thanks for showing up. Race fan, thanks for coming on in and saying good morning, Rob. Good morning, right back to you. Got my cup of coffee sitting right here. It's only 11:30 here on the West Coast, California, where we're broadcasting from here today. Let's see. Flat Six, aka Flat Sixers, saying all right. Good to see everyone. Appreciate you coming on in, Flat Six. Miss Catherine Jones saying, hey, Mr. Rob G and SOR fans, we appreciate you showing on up, Miss Catherine Jones. What are we going to see? We don't know. Kitty Catty Whack coming in with the super sticker. Thank you so much for your awesome support of the show. Who else we have? Operation Shutdown. Hello, Mr. Rob G. Hello, Operation Shutdown. Thanks for coming on in. Also, Undead Jed, thanks for coming in. Frankie B, thanks for coming in. We appreciate you showing up here this morning, right? I'm used to saying this evening, but this morning. Algaray. Hey, Algaray. Thanks for coming on in. Let's see. Athena. I'll just say Athena. I don't want to mess that up, but thank you for coming on in. Jose Sanchez. Thanks for coming on in. Appreciate you showing up. Blast Face. It's going to be the biggest disappointment. I don't know. I beg to differ. If you're expecting alien tech to be the answer, maybe. But then also being that it's NASA, I can understand your perspective on that. We'll kind of talk about that. I have a few things for us to look at before the live stream here for the press conference. Let's see. Julie Russell, appreciate you coming on in. Let's see. Did I say Blast Face? Blast Face. They're about to show some fake-ish. Yeah, they might. And we're going to go ahead and consider that, right? So let's take a look at a couple other things here. Let's see. Oh, hold on here. Why it's not working. We got Anjali out there. Hey, Anjali, thank you for coming on in and showing up here, Anjali. Awesome stuff. Infomax, appreciate you coming on in. Hey, Andrew, thanks for showing up. Lil Mikey, appreciate you coming on in. Matt Goodka, thanks for showing up. And Tony D from Wales. Wow, okay. Appreciate you coming on in. And Lil Mikey, it's a press conference. And so I have some questions about that, right? Because, well, we'll get to it in just a moment. Let me welcome everybody else in real quick here. Anjali Ongaya. We appreciate you, Anjali. And reach out to me on X, Anjali, at Mr. Rob G. Infomax, appreciate you coming on in. Pam Harris, thanks for coming on in. I'm here for you, SOR. Not so much for NASA. I get it. Believe me. I get it. Okay, we are moving down the list here. Walter Kokubinski, appreciate you coming on in. And I know I'm going to miss somebody. Richard Minnick. Wow, Richard Minnick, thanks for coming on in. Long time, buddy. Fernand Mas, appreciate you coming on in. All right, looks like we are current. All right, so 3i Atlas NASA high-rise image release. What do you expect to see here? I'm going to go ahead and bring up some things I put together here for the show. Actually, let me get this set up for you guys. All right, so far, right? So far, we've had various images released, right? Let me go ahead and go over a few things with you. I want to I want to go over the actual first photo, right? Because the photos we're really concerned about are the photos that were taken when 3i Atlas got its closest point to Mars, which was right around October 2nd, October 3rd, right? There were photos released initially from different countries, the ESA, and then also China, European Space Agency, and then also China. And for some reason, our space agency, NASA, has taken all this time to go ahead and release a photo or even make a statement on it, right? And it was blamed on the government shutdown, but I know for sure because I know someone at NASA, they've been at work every day during the shutdown. It wasn't completely shut down, so something to think about. Something to think about as we go ahead and get into this here. So first, this is Tianwen 1. This is China, and actually let me move some stuff out the way for you guys as we look at this here. All right, bring this up full screen. So Tianwen 1 orbiter. This is China's orbiter over on Mars. Obviously not the highest resolution, but they contributed to attempting to show 3i Atlas and what it might be. That is it. Let me go ahead and they actually circle it here. So this is their contribution to the 3i Atlas story. And it's just a blob, right? Not really much we can tell from that. We also had, this is actually, let me read this here. China's Tian-1 orbiter has captured an image of 3i Atlas during this flyby of Mars. Further efforts to shed light on the interstellar anomaly, which some have suspected has alien origins. Next, we have the ESA photo from the European Space Agency, also taken right between, I think they said October 1st and October 7th. So a series of photos, but they show between the 1st and 7th of October, the European Space Agency's ExoMars Trace Gas Orbiter and Mars Express spacecraft turned their eyes towards interstellar comet 3i Atlas as it passed close to Mars. Right? So at least, that's the cool part, right? The cool part about this is it's not just NASA. There are other space agencies out there, and thank God for that. Imagine if NASA was the only outlet to get anything as far as this goes, right? I think we know historically what NASA has done or not done when it comes to being transparent about what happens out there in space. Now, you can have your opinions, but we've talked before about space station feeds just shutting off when something anomalous happens up there. And it's not just happening once or twice, but there are many times where people can account for a situation like that. STS shuttle missions where they have recorded videos of, very anomalous things that they end up explaining away as ice particles, or, if you remember the 13-mile tether that broke off of or separated from the shuttle and drifted off. And there were all these little things, kind of plasma sort of things, kind of moving around the thing. And they said, oh, no, that's just ice. Okay. All right. We can't obviously verify that if we're not out there. But, with that being said, these were the latest photos. Well, some of the latest photos. So right after perihelion happened when 3i Atlas got its closest point to the sun. And that's where one of Avi Loeb's 12 anomalies took place, where I guess it got brighter than the sun at that point. Then it came back around to where we could see it. These were some of the first images that came out after post-perihelion. And this one in particular was taken on November 8th, stacked images of 3i Atlas, the sunward direction opposite to the arrows pointing towards the bottom left corner. And then the very next day, we got this one here, November 9th, which is a stacked deep image of 3i Atlas taken on November 9th. through a combination of 5 exposures, each lasting 3 minutes. With 2 telescopes, the sunward direction is toward the lower left corner, right? And I guess this is probably the best image so far of 3i Atlas, which you're going to be shocked at this. And this is going to set the precedent here, right? Let me go ahead and show you this. And let me go ahead and zoom in on this, because this is pretty clear. This is the latest image taken on November 16th. So about 3 days ago of 3i Atlas. You can see it's pretty detailed. You can see the nucleus there in the middle. We'll actually zoom in on it. You can see a tail. You can see a coma, right? Characteristics of a comet, right? And it's likely a comet. Let's start there. This is likely a comet. And so I don't want anyone to walk away waiting for this extraterrestrial announcement. This is very likely a comet or something new and weird that, you know, we've never seen before. Here's the close-up shot of it. You can see the nucleus there. Now, this view right here, it's very defined. It's a very defined nucleus there. Truthfully, who knows what that is? At the end of the day, this doesn't tell me one way or the other, but then I don't have eyes trained to be able to tell you what's a comet and what isn't, but that's a pretty defined nucleus. Now, if that thing is anywhere near the size that Avi Loeb talked about, 5 to 10 kilometers, that's pretty crazy if you think about it, right? And that's pretty clear. So this wasn't, and actually, let me bring this back. This wasn't taken by some super high-tech telescope on top of a mountain, you know, inside of an observatory. This was taken with this right here. This was the telescope that took that awesome image there. And this is a Celestron Edge HD 800. Not very big at all, right? This is the telescope that took that image. So I'm showing that because if we got that quality, and actually, let me tell you how they got that. The image of 3i Atlas, this one combined, and let me go back to it actually here. Let me get back to that. Okay, so this actually, the image of 3i Atlas combining 24 exposures of 60 seconds each with a 0.2 meter telescope on the Celestron Edge 800 in New Mexico. The image shows multiple jets, both towards and away from the sun. The sunward direction is pointing to the lower left corner, right? And then once again, it was taken by this right here, this telescope. So you would have to think that what we're about to see is a million times more defined than what we just saw. And the reason why I'm saying that is if we don't get some super high level quality photo right here, then you have to question what we're seeing. You have to question what we're being shown. There's no way from the surface of Earth with the telescope we just showed, we get images that clear of 3i Atlas and then not walk away from this high-rise image release being blown away by what we're being shown. So that's one thing I wanted to make sure we covered. Also, I want to talk about hopefully what we should be expecting. Obviously, if you go to the NASA website, there is no 3i Atlas photo at this time, right? This is the high-rise orbiter. This is what is actually taking the photo, or what actually took the photo from Mars, from the orbit of Mars. No atmosphere to obstruct the view, right? The Celestron telescope that we just looked at is from the surface of Earth, so it's looking through the atmosphere. in order to get that image. So I would anticipate what we are about to see to be something mind-blowing. This is what the camera looks like by itself. On to the next. So what will NASA address today? So this is kind of important here, right? Because now I have some expectations. I would hope these are some of the things that I hope get addressed during this press conference. So I would like to see NASA step forward and address Avi Loeb. Will NASA give explanations to Avi Loeb's observation of 12 anomalies in regards to Three Eye Atlas? I would hope that that's the reason why we're having a press conference, right? And if you are unfamiliar with the 12 anomalies, let me go ahead and read those off to you real quick here. So Avi Loeb, the first anomaly, and this is all courtesy of Avi Loeb's Medium page. The first anomaly, its retrograde trajectory is aligned to within 5 degrees with the ecliptic plane of the planets around the sun, with a likelihood of 0.2%. The second anomaly, during July and August, as well as in early November of 2025, it displayed a sunward jet, an anti-tail, that is not an optical illusion from geometric pressure, unlike familiar comets. The third anomaly, its nucleus is about 1 million times more massive than Oumuamua and 1,000 times more massive than 2I Borisov, while moving faster than both, all together with a likelihood of less than 0.1%. The fourth anomaly, its arrival time was fine-tuned to bring it within tens of millions of kilometers from Mars, Venus, and Jupiter, and be observable from Earth at perihelion with a likelihood of 0.005%. 5. Its gas plume contains much more nickel than iron, as found as industrially produced nickel alloys, and a nickel to cyanide ratio that is orders of magnitude larger than that of all known comets, including 2I Borisov, with the likelihood below 1%. Sixth anomaly, its gas plume contains only 4% water by mass, a primary constituent of familiar comets. 7. It shows extreme negative polarization, unprecedented for all known comets, including 2I Borisov, with a likelihood below 1%. 8. It arrived from a direction coincident with the radio of the WOW signal to within 9 degrees, with a likelihood of 0.6%. Number 9, near perihelion, it brightened faster than any known comet and was bluer than the sun. 10, it exhibits sunward and anti-solar jets, which require an unreasonably large surface area in order to absorb enough sunlight needed to sublimate enough ice to feed the mass flux of these jets. 11, near perihelion, it exhibits non-gravitational acceleration, which requires massive evaporation of at least 13% of its mass, whereas preliminary images indicate that the object maintained its integrity and did not break up. And then 12, its tightly collimated jets maintain orientation across 1 million kilometers in multiple directions relative to the sun, despite its measured rotation. Those are the 12 anomalies. So I would like to see NASA address those. Or at least some of those, maybe not all of them. Explain some of them, though, because, if we walk away and we don't have any of those things explained, and we can't simply, take that it's a comet at that point, because as Avi Loeb has pointed out, 1 anomaly, okay, 2 anomalies, all right, 3 anomalies, maybe. When you're getting into 8, 9, 10, 12 anomalies, you have to explain some of those things. So I had a few questions that I would like to see resolved here. One of those questions is, why did it take so long to release the photos? Why did it take so long to release the photos? The high rise has been posting daily pics of Mars throughout the shutdown, every day. So 45 days of Mars photos from high rise, but nothing from 3i Atlas. And I would hope that they answer that question as to why that's the case. If simply a comet, why have a press conference instead of a simple press release? So why are they making a big deal about a comet unless they have some new information to give us, something outside of the ordinary, which is hopefully what I'm anticipating. But what I'm hoping is this is not simply a campaign to discredit the view of Avi Loeb. So my last question would be, and thing that I hope is addressed, is how will NASA view Avi Loeb's suggestion that we should keep an open mind to incoming technological threats? Because I really don't see anything wrong with that, right? We should be open to thinking across the board what something incoming from interstellar space might be. Everyone agrees that there's likely other life out there. We've sent out Voyager 1 50 years ago, which has left the solar system, is in interstellar space. It will arrive somewhere at some point. So why wouldn't you be open to the reverse happening, especially if you have maybe civilizations out there that are billion years older than us, that something that they sent out billions of years ago has finally reached our solar system. So hopefully they show openness to that idea. And I'm hoping that they're not just using this press conference to slam dunk on Avi Loeb. And then just basically, that's essentially the questions I would like to have addressed, and hopefully those get addressed. But we all know, if you remember Donna Hare from the Disclosure Project 2001, she worked in the NASA photo lab as a contractor in the 70s. And she talks about walking into a photo lab in a restricted area. And we'll talk about this because it looks like we only have a few minutes left. But she talks about working in a photo lab, walking into a restricted area, talking to a gentleman who was working on some photos, I guess, of the moon landing and some other things that they were doing. And she saw what appeared to be a round object in one of the photos. She asked the guy what it was. She said, "Is it a UFO?" He kind of didn't say either way if it was or wasn't, and then told her that this is what they do to photos before they release them to the public. So you got to keep that into consideration as well. Whether that story is true or not, is to be determined. But, just like someone said earlier in the chat, will we be shown in this moment what 3i Atlas was? So that's another piece. We have so many amateur astronomers out there, so many different images so far of 3i Atlas, and even this latest one that we just showed. So what they show today should at least line up with what we've been shown before, right? And I'm sure there's going to be people trying to pick that apart. And that's kind of what I hope is addressed. So once again, the 12 anomalies for Avi Loeb, I hope they address some of those, answer some of those questions. And then the three questions that I have: why did it take so long to release the photos when High Rise has been posting photos every day during the shutdown? If it's a comet, why are we doing this big press conference instead of just NASA giving a press release? And then is NASA doing this, putting this press conference on simply to Loeb? And I think we're getting ready to start. I hear some music here, so let's go ahead and get the NASA live show underway. Right, as we wait for that. Hopefully that's not copywritten music, right? I know NASA wouldn't set us up like that. But depending on where, I would like to know what your opinions are after the press conference. So when it's over, we'll come back on, and I'd love to see where your head is at on this, what you thought about it, were some of the questions that you had answered. And like I say, don't go into this, assuming that it's one thing or the other.
Talk about science.
Okay, here we
Good
go.
afternoon and welcome to NASA's Goddard Space Flight Center. We are live today with NASA experts who are excited to share the latest images we have of the interstellar comet 3I Atlas. 3I means third interstellar, and Atlas refers to the NASA-funded Atlas Survey Telescope, which made the discovery. We are joined today by Amit Kshatriya, NASA's Associate Administrator, Nikki Fox, Associate Administrator for NASA's Science Mission Directorate, Sean Domagal-Goldman, Director for the Astrophysics Division, and Tom Statler, Lead Scientist for Solar System Small Bodies in the Planetary Science Division. We'll be taking questions from the media on the phone bridge and through social media, but before we get started, let's learn more about this fascinating comet and share some images. Amit, kick us off.
Hi, everyone. America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet and all evidence points to it being a comet. But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars, from our amazing machines that have been roving the planet for 30 years to look for those things. That is something that's really important for us to learn about and discover. It could be an amazing discovery if and when we can confirm that. But 3I Atlas is a comet. So my colleagues from the Science Mission Directorate will go through the images in detail. But just to give you a peek, here's one of the images from the closest physical instrument we had to the comet, from the HiRISE instrument on our Mars Reconnaissance Orbiter, taken on October 2nd as the comet sailed by at a distance of 19 million miles from the instrument. You can see that Comet 3I Atlas looks like a fuzzy white ball. That ball is a cloud of dust and ice called the coma, which is shed by the comet as it continues its trajectory towards the sun. I'll leave it to my esteemed colleagues to share further details, and I'd like to introduce you to the head of NASA Science, Nikki Fox.
Thank you so much. It is such a rare opportunity for us to be able to observe this interstellar comet. And NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery. Just like Amit said, comets are tiny cosmic snowballs. And by studying them, we can learn about the environment from, basically where they formed, where they came from. This one came from a different environment from our own, and so we're already starting to see some really interesting differences to comets from our own solar system. 3I Atlas, as you heard, is the third known interstellar object to pass through our solar system, the first one being identified in 2017. While these types of interstellar objects have long been predicted, we are just beginning to be able to find them thanks to the newest technologies with our network of Earth-based telescopes, which are designed to find small, fast-moving objects in space. The NASA-funded Atlas Survey Telescope, which made the discovery, is part of NASA's Planetary Defense Network. Our telescopes are always watching the skies to keep us safe, and in doing so, they occasionally make major scientifically interesting discoveries, just like this one. Right away, of course, NASA's Planetary Defense Coordination Office they studied it, and they established that 3I Atlas is not a danger to Earth. In fact, it's at least twice as far away as the distance between the Earth and our sun. On October 30th, the comet itself reached the closest it will ever be to the sun when it crossed just inside Mars's orbit, which is why the image that Amit just showed, he noted it was the closest instrument physically to the comet because the comet was right inside the orbit of Mars. Earth was on the opposite side of the sun, which is about as far away as our planet can possibly be from Mars. It's been clear from the moment of discovery that the comet was going to pass on the opposite side of the sun from where the Earth is. However, it was also clear that its positioning behind the sun was going to make observations from Earth very, very difficult. And that is why we are so happy to have our incredible fleet of NASA science spacecraft all across the solar system. And boy, were they ready for this event. NASA's science assets on board our missions have provided the United States the unique capability to observe 3I Atlas almost the entire time it passes through our celestial neighborhood. Everything NASA science does is interconnected, and nearly 20 mission teams have been working together to really rise to this challenge. 20 mission teams, by the way, and counting. Everything we're learning about the comet is possible because of the distribution of all of the different instruments on our spacecraft with different capabilities. And I'll note that for some of them, we've even pushed our scientific instruments beyond their normal capabilities, beyond the things that they were designed to achieve to allow us to capture this amazing glimpse at this interstellar traveler. In other words, we can study this comet so well because we have many different assets in different locations, observing things in different wavelengths, in different ways, with different instruments, each set of observations providing a different lens for understanding objects in the sky. So NASA's science team has kept watch on 3I Atlas for nearly its entire journey through the solar system for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going. There will be more opportunities to observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026. So the NASA assets that are gathering observations of 3I Atlas include Hubble, the James Webb Space Telescope, TESS, SWIFT, SPHEREX, Perseverance Mars Rover, Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, personal favorite, Parker Solar Probe, Punch, Stereo, and ESA, NASA's SOHO mission. And I'll note that Parker Solar Probe's data were just downloaded yesterday, and indeed, we did catch several glimpses of this amazing comet. The scientific community is hard at work analyzing these images, and everyone, as always, is welcome to take a look. At NASA, we embrace open science. We make all of our data available to the public 24/7, and we invite, in fact, we really want you to tell us what you're observing and what you think about what we're looking at. We're still learning even about what questions we still need to ask, and this, of course, is the scientific process in action. All the data go to a public archive. We get those images as soon as we're able to from all of our eyes in space. As always, I am excited to see what new things we learn about our friendly solar system visitor in the days and, in fact, the years to come. So now I'm going to pass over to Sean. He's going to tell you about what our astrophysics missions have seen. They, of course, were some of the first things to look at the comet, and images from several of them have been available since the beginning of the summer. So I'm going to ask you to set the stage for us. Tell us what we've already seen before we hand over to Tom to tell us all the new stuff. Take it away, Sean.
Thanks, Nikki. Happy to. To give you some background, NASA's astrophysics missions, like all our missions, they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study near-Earth objects or comets like 3I Atlas after they're initially detected. That same powerful gaze that lets these telescopes see distant galaxies, those little red dots you might hear about, they also allow us to observe details about objects like 3I Atlas a little bit sooner. And the earlier we learn about these objects, the earlier we can share this information with the world, including the science community and our partners across the planet that often have ground-based assets or other space-based assets, so that they can conduct additional observations with their telescopes. In this case, our astrophysics missions came together to take advantage of this rare opportunity to study this comet that came to us from outside the solar system. From our flagship space telescopes to smaller missions like TESS and SWIFT, they all have, as Nikki said, different complementary capabilities. They don't just do things that would otherwise be impossible, they do things that even our other great telescopes can't do. So every time we add to the fleet, we add additional capabilities that expand the realm of the possible. In this case, it let us refine the orbit of this structure early on, determine what its structure is and what its composition is, what it is made of. It's a beautiful illustration of why we have not just one space telescope, but a fleet of them, because every one member of that fleet specializes in a different kind of information, contributing a different piece of the puzzle to the total understanding we have from the fleet as a whole. So for example, Old Reliable, NASA's Hubble Space Telescope, celebrated its 35th birthday earlier this year. And not too long after that, in July, it looked at 3I Atlas, not long after we discovered it from the ground. At this point, 3I Atlas was about 277 million miles from Earth. And what Hubble's images revealed was a few things. First, a teardrop-shaped coma of dust coming off that solid, icy nucleus of the comet itself. From these data, astronomers were able to more accurately narrow a few things. Importantly, the size of the nucleus. We now know it's between, at that point actually, we knew it was between 1,400 feet in diameter up to as large as 3.5 miles in diameter. And Hubble also saw that the comet was losing dust, and not just losing it, but losing it at a rate consistent with other previous sun-bound comets that originated from within our solar system, consistent with the physics that we figured out from watching those objects. Now, the last thing Hubble did is it gave us a better understanding of the orbit of this object. Tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope. We added this to our fleet early in this decade. We didn't have it when the last two interstellar comets came around. Now, what James Webb did, and its companion SPHEREX, which we only launched at the beginning of this year, is it added infrared observations. The power of infrared observations is, these are colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints from the things that the objects are made of. So with these infrared observations with James Webb and SPHEREX, we detected an abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust surrounding that comet as it approaches the sun. Those molecular fingerprints I mentioned, those are the little like science wiggles you might see in the top right of these images. We now know from seeing those science wiggles, those fingerprints of those molecules, that the comet has a nucleus rich in carbon dioxide as well as the presence of water ice. Now, the ratio, like we can not just say that these things are there, we can also say, what's the ratio of carbon dioxide to water? And we now know that. We know it's larger than what we usually see in solar system objects. But there's a lot of natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away. But there's other well-understood processes that could also explain it. I'll just, to put this in context, every time we look beyond our solar system and we look at the ratios of carbon dioxide to water, we see, whether it's a star or a planet, different ratios than we see in the solar system. And that's true for this comet as well. So it could mean, and this is the last theory of why those ratios could be different, that these ices could have been exposed to higher levels of radiation than comets in our own system. Or, as I said before, could be that the comet just formed from a region where carbon dioxide ice was particularly abundant and different from our solar system. Other missions like our SWIFT spacecraft, which studies X-rays and gamma rays, have also observed the comet. Teams even looked back through data from our TESS mission, which was designed to look at exoplanets, and found observations of the comet as early as May. That information is helping us understand the comet's history before it got closer and when those other observatories pointed at it once we knew where it was. Now that the comet is near, relatively speaking, our planetary and heliophysics missions have joined in to tell us more. And now I'm going to turn it over to my colleague Tom Statler to talk about some of those new images.
All right, thanks very much, Sean. Before we get started, I just want to remind everybody of where we are, who is where in this play. As you saw in the animations while Nikki was speaking, the sun, of course, is at the center of our solar system. The planets are orbiting around the sun, and in this case, Comet 3I Atlas has come through on a trajectory in the opposite direction and has arrived at its closest point to the sun when the Earth was on the wrong side for us to conveniently observe. But Mars was on the correct side of the sun, and our Mars assets were able to observe the comet, and also several of our other spacecraft were on the correct side of the sun. So the scientific community is really excited about the comet and about these new observations. I'm tremendously excited to help share them with you today. This is a new scientific opportunity, and it's a new window into the makeups and histories of other solar systems. We're just beginning to learn about these types of objects and figure out what are the right questions we should ask about them. Now, let me start by going directly to what we were able to see at the beginning of September, when Psyche was able to see the mission. So before that, though, in August, we organized a workshop. We organized a coordination session for the missions across the NASA fleet that had good opportunities for potentially observing 3I Atlas, so that we could all share observing plans and knew what was going to be possible with our assets. I can't emphasize enough now how, thanks to the cooperation of so many mission teams, we will be accumulating a wealth of data on this comet that the science community will be digging into for years. Now, let's go back to September, and I can show you a sampling of the images collected by our different mission teams. To set the context, you're going to see a comet that's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big. Nothing is ever really as close as you like, and all of these observations are very, very difficult. It's a little bit as if our NASA spacecraft were at a baseball game, watching the game from different places in the stadium. Everybody's got a camera, and they're trying to get a picture of the ball, and nobody has a perfect view, and everybody has a different camera. Now, let's return to September and see the first images from the Psyche spacecraft. NASA's Psyche mission acquired 4 broadband black and white images of the comet over the course of 8 hours on September 8th and 9th, 2025. The comet was about 33 million miles from the spacecraft at that time, and you can see in the image the large frame where the comet was seen at different times. Down in the bottom left is a blow-up, a stack in addition of all of those observations. The Psyche spacecraft is on its way to an asteroid in the main asteroid belt that's also named Psyche. And these images were the first captured from this perspective. Now, if you think in that lower left, you're not seeing very much, just wait a minute, you'll see more. Now, the following week in September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image made by adding up a series of individual exposures that were taken on September 16th. Lucy is on its way to study asteroids that share Jupiter's orbit around the sun, called the Trojan asteroids. Lucy was 240 million miles away from 3I Atlas, which is circled in the center, when its high-resolution LORRI camera caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3I Atlas, and its tail, a smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before in solar system comets. For scale, this image spans about 1/3 the width of the full moon as you'd see it on the sky. Of course, at the distance of the comet, that's a much, much larger region of space than the moon. Now, this looks a little different from the Psyche image. Part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. Seeing a comet's coma in different lighting geometries, with the sun coming from different directions, is one of the key ways to learn about the physical properties of the dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is, so that you can see it backlit. We could not get this view from the vantage point of the Earth. So combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand both the three-dimensional structure of the comet and the nature of the dust. It's a rare opportunity to compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture from the MAVEN spacecraft at Mars. At the beginning of October, 3I Atlas passed within 20 million miles of Mars, which gave our Mars spacecraft an opportunity for a close-up. And earlier you saw the image that Ahmed shared from our Mars Reconnaissance Orbiter. MAVEN is another Mars orbiter that has been studying the Martian atmosphere since 2014. Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the science wiggles that Sean was just talking about. This is some of those science wiggles where the instrument, the spectrograph, the ultraviolet spectrograph on MAVEN has looked at the comet and also split up the ultraviolet light according to color. So you're seeing three different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from comet 3I Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case, behind the sun from the telescope's point of view. You'll be able to see the rest of the images on our 3I Atlas website, go.nasa.gov/3I-Atlas. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with. and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. But the answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press *1 to enter the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observation, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one. The shape of the nucleus is also difficult to pin down because generally we're not resolving it in our observations. It's obscured by the dust, and especially it's obscured by the reflected sunlight off of the dust in the inner part of the coma. But what observers from the ground have been able to do is observe the brightness of the center of the comet over time to see if there's a modulation of that brightness that would be an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. It's not, doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin. It would be great, it would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place. And the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from some very old population, of solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself, which gives me goosebumps to think about, frankly, because that means the 3I Atlas is not just a window into another solar system, it's a window into the deep past, and so deep in the past that it predates even the formation of our Earth and our sun.
All right, we'll take our next question from the phone bridge from Bill Harwood with CBS. Bill, if you're talking, we can't hear you.
Try me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. You know, I mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft? I doubt you did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of this data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got a point. It's natural to wonder, what it is. And we actually love, as Amit said, we love that the world wandered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we found it. And even, I was interested, I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool. I just heard that from Sean. But, we were very quickly able to look for sort of, the easiest thing to do, I'll put it in a different way, is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for. And so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else. And that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur. And now, of course, we know better how to look for them. And we now have this amazing Atlas array. We're expecting we'll find a lot more of them. But it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any technosignatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool. It's from something that predates even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little bit, Tom?
You were geeking out so expertly, Nikki, to begin with. So that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine if you're fortunate enough to have grown up in Hawaii and you only drank Kona coffee, you love your Kona coffee, and then somebody says to you, well, gee, have you tried Sumatran? You're going to say, well, do you expect it to be different? And they'll say, why don't you try this? And you try it and you say, wow, that's really different. And you realize, well, I expected this to be different because it was from someplace else. It was a different environment in Sumatra. Now, does that one sip of coffee tell you everything about the weather in Sumatra and the soil and the people who harvest the coffee? Bless them. Of course not, but it's different, and yet it's still coffee. And that's what we have in this case. We have a cometary body. It behaves, it resembles the homegrown comets that we have in our solar system, and yet it's excitingly different in particular ways. It does the same thing comets do. It evaporates carbon dioxide gas. It evaporates water. But it's evaporating more carbon dioxide compared to water. So that's a very interesting thing. Comets evaporate dust, and the dust is broken down. The minerals are broken down by the ultraviolet light of the sun. And comets, we know comets put out nickel, they put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting, really remarkable, and something to be studied in the future. So we're always interested in new ideas. We're always interested in new suggestions, and all ideas are good when they're born. But those that stand the test of time, those that stand up to testing, those that are supported by the evidence, are the ones that survive.
All right, we'll take our next question on the phone bridge. And that one comes from Matthew Glasser with ABC.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the universe? Are there key things you're looking for as you start to analyze this data? And are you excited about anything in particular when it comes to better understanding how things are working out there?
Sure, I can take that. Every new object we discover is a new piece in the puzzle. What we're trying to do always is to understand the universe. That's part of the NASA mission, is to understand the solar system, understand the universe, understand the origin of planets, the origin of life. And that is a huge question. And we get little bits, little clues to parts of that puzzle, and we start trying to put that puzzle together. We have gained tremendous amount of information from hundreds of years of astronomical observation and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects. The way they are distributed through space in the outer solar system show us clues to how the orbits of the major planets may have changed over time in the early solar system. A fascinating thing, and questions that we would never have thought to ask before we knew about these trans-Neptunian objects. Now, interstellar objects, like I said before, are new windows, and it's windows that we've never even looked out of before. So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions, the elemental abundances, the mineral abundances may have been very, very different. It would be a different picture if we were seeing the first 3 interstellar objects and we'd say, gee, those look exactly like our homegrown comets. That would have been really interesting, and we would have said, well, maybe our galaxy is a boring place because every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as frozen fossils from their moments of formation, including the things in and now from beyond our solar system. Or in some cases, we point our telescopes at other debris disks, which is just, a whole system full of these small bodies. And so now what this will let us do is tell that story in a broader context between the detailed and large library of data we have on those origins of our own solar system, and how volatiles were delivered to make life possible here on Earth, combined with that big picture of other systems of the dust spread throughout those other solar systems. And now with this visitor that got frozen in time from somewhere beyond our solar system, and that small picture of what that was like when that formed.
And the fact that I love the sort of thought of it as that frozen fossil, almost frozen time capsule. We're kind of privileged. I mean, it's come into our solar system, our sun. We know, we think it hasn't seen a star for a long time. So it's actually warming up and giving us more information. It isn't just about a frozen object coming through and us sort of saying, oh, look, there's a frozen object moving through. But as it's almost waking up and showing us its composition, and that's allowing us to be able to do this great science. If it had just remained frozen all the time, we wouldn't know much about it. But it is the sort of its rendezvous with our star that is allowing us to really do this amazing science. And that to me it makes me feel almost privileged to actually be able to unlock the secrets as this cometary object is coming around and rendezvousing and interacting with our solar system.
All right, let's head over to social media. Nina on X asks, will it hit any planets in our solar system?
No, it will not. I think if you, obviously we're not going to run it again, but please, go online, take a look at go.nasa.gov/3i-atlas and take a look at the trajectory. I kind of talked through it briefly. Tom talked through it, and you can sort of see where those planets are. And remember this, even though it's exciting and it's coming through, space is huge, as both Sean and Tom talked about. And so the probability of it actually hitting anything is super, super small. You have to have all these things aligned to actually be able to do it. But certainly the objects in our solar system will be just fine.
And we have another question from social media from Astronomeum. They ask, what makes Comet 3I Atlas so different and intriguing compared to the other interstellar comets?
Tom, you want to take that?
The other interstellar objects. We say interstellar objects because not all of them were comets. So the first one was discovered in 2017. That was 1I Oumuamua that behaved very much like an asteroid. Again, a little bit like 3I Atlas, a very interesting asteroid, in some ways different from the asteroids we're accustomed to seeing in our solar system. For one thing, it was seemed to be very, very elongated, and while it was inactive, it seemed to be an inert, mostly rocky object. It did show indirect indications that it was evaporating gases in some way. It wasn't around long enough for us to get really, really comprehensive long duration observations and understand exactly what it was doing. It was the very first one. We saw it for a short time when it was on its way out, in fact, and so we didn't get a great view of that. The second object, 2I Borisov, discovered in 2019, behaved, it was a comet. It was definitely a comet. It behaved in a lot of ways like our homegrown solar system comets, in many ways like 3I Atlas. Its properties were more in line with what we're used to seeing, and the comet observers regarded it as very much akin to our solar system comets, although in some ways a little bit at the edge of what we're used to seeing. 3I Atlas is in a lot of ways like 2I Borisov, but a bit more out there in terms of things like the carbon dioxide to water ratio.
All right, Svetlana on LinkedIn asks, will the observational data from this campaign be available for open analysis?
Absolutely. Every piece of NASA data, we are delighted to share. We've had open data policy at NASA for a long time. We make a big effort not just to release the data, but also to make sure it's usable, so you can get the tools and things to actually analyze the data as well. And we invite everybody to look at this comet with us. If you're able to take your own images through like citizen science programs, we love that too. We love everybody to be sharing in the joy of NASA science as we take every opportunity to take advantage of these incredible visitors to our solar system.
And that citizen science campaign, that includes work that citizens help us do to identify small bodies in our solar system. And so if you really want to get engaged beyond just looking at the data, you can help us generate new data and find other objects for us to study.
Yep, the big one, our solar, our SOHO, big comet finder, big comet tracker. So many of those comets discovered by our citizen scientists. So keep those observations coming.
All right, we'll head back over to the phone bridge. Our next question comes from Ken Chang with the New York Times.
Hi, thank you. This is for Tom and Nikki. One, of the measurements made so far, what is uniquely different about this comet, other than the trajectory, of course? And two, since perihelion, it looks like there are multiple jets. I was wondering if you could talk about that and the speculation that it might have exploded. Thank you.
Go ahead.
Yeah, thanks, Ken. So some of the differences I already mentioned is the ratio, the carbon dioxide to water ratio, the nickel to iron ratio. Also, there were ground-based observations noting that the polarization of the light reflected off the dust was also unusual. So that's telling us some interesting things about the dust. There are other indications that the physical properties of this dust, maybe the grain size distribution, might be different from the sorts of things that we're used to. The appearance of a sunward tail early on in the trajectory was part of that, an indication that the dust was being pushed off the comet on the sunward side, and then it took a while for the solar radiation pressure to push it back the other way. That's been seen before in other comets, but not very often. I'm sorry, Ken, what was the second part of the question?
Explosion.
Did it?
Perihelion.
Jets. Yeah. The jets, right. So seeing more activity are in the inner coma around the nucleus right around the time of perihelion, when it's being warmed most intensely, is something that happens frequently. That's something the comet observers are going to be very, very excited about. It does take some time to figure out, because it takes time for the actual event that happens on the surface to propagate out to a distance where you can see it with the telescope, but people are going to be mapping what jets there are. It doesn't necessarily mean there was an explosion. Jets can also just mean there are particularly active areas on the surface of the comet where more volatile stuff is evaporating in that one spot than elsewhere and jetting out. We saw this a decade ago with the ESA Rosetta mission at Comet 67P. It got up close and personal with the nucleus and saw frequently that there were jets coming out from specific places on the nucleus of the comet. So that could very well be what's going on here. Can't tell for sure, but that's the sort of thing we've seen before.
The other thing I just want to say that we're expecting to see as more stuff gets thrown off this comet in these jets is at those warmer temperatures, additional things can bake off of it, additional gases can bake off. And so we do expect the composition of the coma to potentially change, or those jets to change over time. And looking at the details of what other molecules we detect beyond the carbon dioxide and water we mentioned is also going to be interesting, especially for that sort of like, what was this stuff, what was the area in this, what was this stuff made of in the area it was made like long time ago.
Our next question is from David Chandler with Sky and Telescope.
Yes, a couple of things. Have you any of these observations showing you anything about any non-gravitational accelerations at this point? And also, can you say a little bit about coming attractions? What observations are in the pipeline that have been made but not released yet? I think the MRO high-rise observations, has that been released yet? And what else is there that's either in the can and waiting to come out, or observations that will be made over the coming weeks as the object comes closer to Earth?
Mm-hmm. I can answer some of that about the non-gravitational accelerations. This is something that we look very closely at for every comet, because that's always something that happens. And just to back up to explain what the question is that as comets evaporate, they are blowing off gas, they are blowing off dust, and every time something gets pushed off the comet, that acts like a little rocket engine at that moment and pushes in the other direction. And so it's very, very common to see comets have subtle changes in their orbits as a result of these little rocket forces, just called non-gravitational accelerations. So this is being monitored very closely. I spoke to our orbit determination team of the Jet Propulsion Laboratory earlier this week, and what they said is that this is being monitored. There are some changes to the orbit, but the uncertainties are still fairly large. It's difficult because we can't see the nucleus directly. It's difficult to get a very, very precise track on exactly where it's going. But so far, the non-gravitational accelerations have been very much on par with the sort that we see in solar system comets.
In terms of future observations, this is a situation where, because this is only the third time we've had an opportunity to look at an object like this, everyone that is in control of a telescope wants to look at it because it's a fascinating and rare opportunity. I know that our colleagues from the Keck Observatory have looked at it. I believe that we're going to look at it again with JWST in December. We have some other ground-based facilities that are giving us additional compositional information as those additional molecules bake off of 3I Atlas. Those are the things I'm aware of. There's probably a lot more that I'm not, because like I said, like every astronomer wants to get data on this thing because it's such a rare opportunity.
Yeah, and the high-rise image that you asked about specifically, Amit kind of rolled that out at the beginning. So please take a look at that image. I think Sean is not bragging a lot on what these astrophysics telescope. I don't know why, but because we are able to look at it in infrared with the James Webb Space Telescope, that will be the last time we can see the comet. So as it is exiting the solar system and getting further and further away, the James Webb Space Telescope will actually be able to track it longer than anyone else, partly because of its ability to kind of look long and deep rather than sort of across and wide, and the fact that it looks in the ultraviolet, so in the infrared, so it can kind of see the dark objects. And so I'm really excited about just sort of, tracking it to the very end. Also noted we're downlinking data from missions. I mentioned Parker Solar Probe because I just heard before we came on that we'd got some data and we'd seen the comet. I haven't had time to look at the data yet, but all of those things are coming up as we are getting more and more data coming down to us from those missions. And then as both Sean and Tom talked about, just really making sure we're sharpening up those images and really, making sure they're calibrated. Right now, we're putting out almost the raw images. We're putting out things quickly so everyone can see them, but we'll take some time and do some real sort of deep looking into those and do some more of the spectroscopy. Tom showed a really great example of kind of looking through the atmosphere of Mars, take out that hydrogen, take out the hydrogen from our solar system, and then let us look at the hydrogen that's coming from the comet. So we'll be doing a lot more of that as we move on to do great things with NASA science.
All right, that's a great lead into our next question on social media. Elijah on X asks, what kind of processing were the images subjected to and why did they need it?
Want to take that?
The images that were released received the sort of standard processing that we do between the raw data that comes down into a telescope. That, as Nikki said, we need to make sure for scientific accuracy that they're calibrated against the other observations, and we account for anything that the telescope is doing in that moment. And so that it would be our standard set of calibrations and normalizations for a object of this type, which is to say a comet.
I can add a little bit more to that. As Nikki said, our desire was to get these images out to the public as quickly as possible. And so there are some image artifacts in there that you'll see. And I can speak to the Lucy image that you saw previously. If you look at the comet, you'll see some blobs around the comet. The little blobs, faint blobs around the comet are not real. It came from the fact that in order to get this particular view, it was necessary, which is this backlit view, the team had to turn the spacecraft to face more toward the sun than it generally does. And so that means some part of the spacecraft were in the sun, and some of that bright, the sunlight reflected off parts of the spacecraft got into the camera, and that resulted in those little blobs. So that's an example of processing that has yet to be done to figure out exactly what that scattered light contribution was and remove that from the image so that what we show in the image is entirely what was there in the sky and not something just made by sun glints off the spacecraft hardware.
Yeah, and sometimes I think you showed the Soho image where we actually stacked a couple of images, because a single image, you wouldn't be able to see it. It would be too faint. But if we stack a couple of images together, then you can actually start to really make out what that comet looks like.
Okay, next, Gail on Facebook asks, how can an object like 3I Atlas come from so far, moving as fast as it is, and not hit anything?
Orbital dynamics and space is really, really huge. And so, it is amazing to think about just how big even our solar system. And so to give you the Voyager spacecraft, Voyager 1 is now 1 light day away from Earth, which means when we send a command or we send a photon from Earth, it takes a full day for that photon to arrive at Voyager. And Voyager is only just outside kind of what we think of as the edge of our solar system. And so space is vast. Yes, this thing is moving quickly, and yes, it came from outside our solar system. But the probability of it actually hitting something is so small, because everything has to align. It's also not quite in the ecliptic plane. It's not quite in like our normal. If you think about sort of looking side on at our solar system with the sun, and then you put the planets kind of in a row. Normally, everything sort of orbits in this plane. This is slightly tipped. Not unusual, because it's not gravitationally bound to our sun, but it's slightly tipped. That makes the probability of it hitting it almost even greater.
If I can play with a scale model solar, if you make a scale model solar system where the sun and the Earth are 1 foot apart, that's about 1 foot. The sun is a P. The Earth, you need a magnifying glass to see, it's so small. The entire solar system will just barely fit in your house if you squeeze a little bit, and the next nearest star is over 50 miles away. So they call it space for a reason. Most of it is space.
Okay, we'll head back to our phone bridge. Our next question is from Brandon Spector with Live Science.
Hi, I wanted to ask about the age of the comet. You mentioned there's circumstantial evidence that it's much older than our solar system, but how can we constrain that age a little more? And what will that tell us if it is indeed much, much older than the solar system?
I can start that, but I'm going to pass it to Sean to talk about ages in the galaxy.
Okay.
So, cutting to the end, the bottom line is going to be, it's probably going to be really hard to get a more precise figure from one object. I think what we're looking at in the future, as we discover more of these, when we get to the point where we have maybe a few dozen of them and look at the distribution and properties, we may be able to get a better handle on what the distribution of ages is. So what's going on here is that it takes the sun 240 million years to orbit around the center of the galaxy, and we're doing that with a neighborhood of stars. So we're all going around the center of the galaxy. The relative motions between stars in our solar neighborhood is sort of 10-ish, 15, and sorry, I have all these numbers in my head in metric because that's the way I learned them, but 10 or 15-ish kilometers per second. So what is that? That's about 25,000 miles an hour, I think. And 3I Atlas is coming through at a speed of 60-something kilometers per second. So that's 3 times faster than the average of our local neighborhood, which is telling us that it's coming from a different population from what we have generally around us. Now, Sean will be able to clarify the age dispersion relation in our galaxy, which tells us, which has been discovered over the last century studying stars in the galaxy, that the relative speeds of stars is an indicator of age. Stars that formed older in our galaxy over time increase their random motions for reasons that Sean will explain. And so that's the circumstantial evidence that makes us think that 3I Atlas came from a solar system that had larger motions relative to our solar neighborhood and is older. But it is a circumstantial and probabilistic argument.
So I'm just going to take this opportunity to brag about our telescopes and the James Webb Space Telescope in particular.
Go for it.
This blows my mind. We have data from galaxies closer to the origin of the universe than we have data from rocks closer to the origin of Earth, right? In other words, like if you pick up the oldest rock that we have from Earth, it is further away from the origin of Earth in terms of hundreds of millions of years than the amount of time there was between the origin of the universe and the earliest galaxies that JWST has now observed. And that's part of this story of how well we understand not just the history of our home planet, but the history of the entire universe that it's a part of. And now this is just another part of that story of the local neighborhood that our solar system is a part of.
All right, our last question for today comes from X and asks if we can see grains of sand on Mars. How is the clearest photo we can see for 3I Atlas what we've seen?
So because we're closer to the grains of sands on Mars, right? And so the JWST can only get like these single pixel blobs of the faintest galaxies, the furthest away galaxies in our universe. And because 3I Atlas is in our solar system, we can get the images and the compositional information with JWST. As it got closer to some of the planetary spacecraft Tom was talking about, they can't even see these galaxies, but because 3I Atlas was closer to them than they were to JW, they got really good images of the object as it passed by.
Right, as you said, we can image individual grains on Mars because we have spacecraft standing on Mars.
Right.
But even our closest spacecraft to 3I Atlas, we're still 19 million miles away.
And it's going too fast for us to send something there to intercept and get that close to it. So that's just not that we just don't have the. If we could. We would, we would be there up close and getting those grains.
All right, well, that's all the time we have for today. Thank you so much for joining us. Be sure to follow along with NASA as we continue to observe 3I Atlas. Find new images, detailed information, and resources by visiting go.nasa.gov/3I-Atlas and by following NASA Solar System on social media. Thanks for joining.
Okay. Now we're gonna go ahead and see what you guys thought about that, right? I love to see your comments and you know, we pretty much expected that they were going to say that it was a comet. I thought they would at least. Here's my problem. This is my problem with this. They shouldn't have had to ask those the questions that were asked, especially some of the more important ones, like why is the image so blurry, and what's up with the jets on this thing, and the gravitational acceleration. Like, these are things I feel like NASA should have already had in their presentation. These are the things that they should have been answering. They didn't really say much. They didn't really show much. And tell me how can they say that these are the best images they could get? And I understand when the question came up about how could you get a grain of sand on Mars versus a blurry object in this. Now, here's the thing. We already talked about this, but I'm going to show it again because it doesn't make sense. This image is from November 16th. Let me bring this back up again because they have to make this make sense. We're going to go into a couple things. I'm going to read your comments here in a moment, but I just have to at least address this real quick. Pretty much none of Avi Loeb's 12 anomalies, except for a couple of them, the gravitation acceleration question that was brought up, the jets. There's at least 9 anomalies that Avi Loeb pointed out that were not answered here. This is 3i Atlas taken on November 16th from the surface of Earth. And I found this image. This is on Avi Loeb's Medium page. It's aviloeb.medium.com, I believe. Zoomed in. And then even zoomed in even further. How do we get this from the surface of Earth from an amateur astronomer who recorded this with this Celestron Edge HD 800? How does that happen when NASA has the high-rise orbiter with the camera that looks like this? How's that possible? This is NASA, for whatever reason, likes to stay in the realm of conspiracy, right? Now, we know there's some things that we definitely know. And my other question was what was actually asked at the end of the press conference, which is, why isn't the image as clear as what was taken by this Celestron telescope? So what we do know, and here's part of the problem, right? This is why NASA has the problems that they have. Because we have, I'm going to go over, this is Donna Hare. We were talking about her before the presentation started. Donna Hare, who, if you recall, was part of Stephen Greer's Disclosure Project 2001, which was, I think, the best one. And she gave testimony, and all of the presenters in Disclosure Project 2001 all stated that they would be willing to take this information they were given and present it in front of Congress. Obviously, this is way before Congress was even listening to UFO information. But I'm going to read a little clip of what she said. Donna Hare, this is part of her testimony. She says some things before this, but it picks up as this. Let me actually preface this. So this is in the 1970s when this happened. She worked in the NASA photo lab as a contractor. She stated on this particular day, she walked into a photo lab in the restricted area, and this was between missions. One of the gentlemen I have been friends with, and I still talk to occasionally, he pointed my attention to one area of this mosaic. It was one panel of a mosaic, which are several panels put together to form a larger picture. And these were, I believe they were satellite pictures. I'm not sure, but they were aerial and they were looking down. And I said, this is really interesting. He explained everything with a smile on his face. He said, look over there. And I looked, and one of the photo panels, I saw a round white dot. And at this time, is very sharp lines on it. And I said to him, what is that? Is that a dot on the emulsion? And then he's grinning and he says, dots on the emulsion don't leave shadows on the ground. And there was a round shadow with the right angle at the correct angle, the sun shining on the trees. I saw pine trees. I didn't see a coastline. I don't know where this was, but I looked at him and I was pretty startled because I've worked out there several years and never seen anything like this. Never heard of anything like this. And I said, is this a UFO? And he's smiling at me. He says, I can't tell you. I can't tell you that. What I knew he meant was it was a UFO, but he couldn't tell me. So I said, what are you going to do with this information? And he said, well, we always have to airbrush them out before we sell them to the public. And I was just amazed that they had a protocol in place for getting rid of UFO pictures. Now, to be believed or not to be believed, this was her testimony. And she stated that this is when she worked in the NASA photo lab as a contractor back in the 1970s. We also know that one of the shuttle missions, one of the moon missions, I don't remember which Apollo mission it was, but I know they had a picture of a spacewalk by a particular astronaut. Turned out to be an altered image of something done here on Earth, essentially. So they've been caught faking photos. Now, whatever the explanation is for that spacewalk photo, that was determined to be fake. They put the real image aside of the fake image, right? And then you have testimony that comes later on after this with Donna Hare talking about her experience working in the NASA photo lab. Then we get an Earth-based photo, once again, of this comet with this type of resolution. And I'll read how they put this together again. So this is an image of 3I Atlas combining 24 exposures of 60 seconds each with a 0.2 meter telescope, which is the Celestron Edge HD 800 in New Mexico. The image shows multiple jets both towards and away from the sun. The sunward direction is pointing to the lower left corner. For me, there's no reason why they should have been able to get a better picture of this comet with this versus the camera that we see right here. Doesn't make sense. So what I'm going to do is read your comments, because I don't think there were only a couple things that were addressed that I felt like were addressed, and not really the important stuff, right? Just giving us a science lesson, essentially, is what happened here about comets, in general comets. I don't think even necessarily the focus was 3I Atlas. We got more of a conversation on the anatomy of comets and you know what makes up comets. I don't think we actually had this addressed. And some of those questions weren't really great questions. They did get a couple in there that I wanted to ask, so that was cool. But I really don't feel like what did we get here? And this is why, you know, people say never a straight answer. NASA, never a straight answer. My thing, I say NASA never actually sees anything. NASA never actually sees aliens, or never acknowledges space aliens, never actually sees anything. And it's been historically, we've seen, and we come to a conclusion by watching the International Space Station, which is a live feed. Supposedly this is the illusion of transparency, but we know we've seen those cameras shut off at peculiar times. We know that we've seen space shuttle missions, the video from space shuttle missions that depict weird things out there. They don't address them. And remember, this is the same, and this was very similar. This press conference reminded me very much of the press conference with Aero, the joint conference with Aero and NASA. It is impossible that they are not recording things and they're not seeing things. It is literally impossible. We have images. We have radar images from military jets. We have citizens who have taken images of a lot of various things, but NASA doesn't have anything. They have absolutely nothing. Doesn't make sense. Doesn't make sense. So let me see what everybody, what did you guys think about this conversation? I mean, I've been reading the chat during the press conference, and I know you guys weren't really feeling it, but let me try to go back a little bit here. Anjali says, what's sad is that those 4 presenters are busy smelling each other's farts and patting one another on the back for a job well done. It was contrived. I don't feel like, there were all these days that passed. The high-rise orbiter had been sending images back to Earth of the surface of Mars, daily photographs throughout the shutdown. But we don't get this until today. And then it's underwhelming. It's, we showed I was expecting something better than, let me go back here. Obviously this was the ExoMars Trace Gas Orbiter, which was from the European Space Agency. That's better than what we just saw from NASA. This is probably the worst one, the Tianwen orbiter from China, which is pretty great, but really, the NASA image wasn't too much better, which is amazing to me that they're able to sit up and do that. Why even show it if it wasn't going to stand up to anything else that had been released? I know they saw this other image because it's being circulated around the community. This beautiful picture here. There's no way they shouldn't have been able to get something like this from the Mars high-rise camera. So let me see here. Hank Salat says that was a waste of time. Tony D says not a serious analysis. I like that. Yeah. Integrationing. Not about to say anything. If we did. No actual spending accountability. I like that too. Luscious Jules, buy something. Thumbs up. Might as well, since you're right here, spacedoutradio.com. Also, let's take a moment to, if you would mind, I know a lot of you watching from X, and we do appreciate you showing up there. You can, if you would mind, if you're not already following us, I imagine you might be, hit the follow button. Also, you could find me over at Mr. Rob G, right here on X and on YouTube. So we'd appreciate you guys coming back and hanging out. Tanks a lot says, nah, okay. Lester Jules. All right, let me see. Paramar. Sorry if I wasn't clear. I meant that I believe Karen's story about NASA airbrushing pictures before releasing them. Yeah. I mean, they were already caught faking pictures. So that's, once you're caught in a situation like that, you can't, you lose trust in the community. You have to regain trust. And this was an opportunity for them to regain trust, because if it's just a comet, which I believe it is, then they should have shown something amazing. Why would you hold a press conference if you didn't have amazing data? This should have been something just released in a press release, right? A press release. And then if you needed more time to process the data, to stack the images, to get us something more clear, then you hold the press conference. But this was very underwhelming. They had to know that. They had to know that the community, and not just the UFO community, but just the world has been waiting to see what this is. And the premier space agency brings lackluster data. There's amateur astronomers doing better work, which is amazing to me, because we're not funding the amateur astronomers. We're funding NASA, and they're bringing nothing burgers to the table. This is nothing burger after nothing burger. If you go back to the Aero conference, and literally, let's go back to the beginning of NASA. Let's go back. Truthfully, I don't know of a time when they really came through, and seemed like they were being truthful. There's been like this whole feeling behind, because they're a government agency, that they're not showing us everything. And there's just too many examples over time, and it can't all be conspiracies. That's the thing, right? I can see maybe we're thinking too hard about some of the stuff, but it can't, if it walks like a duck, it quacks like a duck, it's a duck, right? So let me see, what else do we have here? All right. Yep. It says hello to the audience on X 634. Yeah, definitely. We definitely shouted out everybody on X. We appreciate you guys out there. Thanks for coming in and watching the show with us, hanging out with us. Let's see. Yep. Now the question is, why continue to lie? I know. And see, that's the thing. I don't want to just be on the side of saying, oh, NASA, you're lying, in with the appearance of I'm saying that because I want this to be space aliens. I'm totally fine with this being a comet. And I'm expecting to see the most beautiful image of a comet that we've ever seen. That's how I'm coming into this, and I think that's how most of us are coming into this. But when you come with lackluster data, then you leave question marks there. And then you leave, for the people that want it to be space aliens, you just leave room for that conspiracy to kind of grow. And it seems like that's been the thing. That's the way that they approach this all the time. They want to leave mystery there in room for there to be a conspiracy theory. Just looking at your comments here. Yep, Paramore. Okay, integration. Let's see, Donna here. Yeah, that's the statement that I read earlier. Donna here. Let's see. Anjali and Gaia, they are an intelligence agency. And that, you can't help but walk away from it and feel that way, right? You can't help but walk away and feel that way. I wasn't expecting anything more than them showing us something amazing, some sort of amazing natural thing out there, and at least talking to how it's something new that we don't understand, and which they sort of talk to, but at the same time, it just seems like they were, in their presentation, they were avoiding what the questions were. And the one of the gentlemen on that stage said that during this shutdown, they couldn't really work, but they were working. And he was seeing all the interactions on social media, and was encouraged with the interaction of the community. So then that lets me know that you also saw what some of the opinions were on what this was, and for you to have all that time and have watched it and looked at all these different posts, I would imagine you would have put that into your presentation or answered some of those questions. Why did we have to ask you in the Q&A session when you could have addressed that during your press conference, right? It seems like they were totally attempting to avoid it. And then when they were asked these questions, there was a lot of stuttering, and it just doesn't make you feel good about transparent. If they're really being transparent, it doesn't really seem to be that way. Let's see. Paramore, this press conference was about optics. They wanted to appear transparent. You're right that a press release would have covered this info. That's all I'm saying. All this to do for what? Got the world's attention. Press conference at noon, 3 p.m. Eastern. Be there. And then you get there, and what do you get? JSCO. This was far worse than I even thought it would be. True. And yeah, true. Blastface, very disappointed. Andrew, I expected comment. I walk away more confused, and perhaps that is the point. Perfectly said, because that's exactly what I'm saying. Right? This was an opportunity to get, people interested in space and the natural things that are out there, right? You had everyone's attention. Hillbilly Herb, a poor attempt to show that they're still involved in space exploration as opposed to military intelligence. They had too much time. This should have been the perfect press conference. So I imagine a world where if the government wasn't shut down, right? So that means October 2nd or 3rd, when this happened, there would have been a press conference probably within a few days of that. And if that was the case, I could expect maybe not having all the data, within a few days of the event, but we're talking about a month and a half out, and then this is what we get. Let's see, Andrew, there was no new information at all. Correct. It's a good idea. I mean, Kai Snyder, what department of NASA do I send my FOIA request? I'll probably just ignore it anyway. John Greenwald shows that it never hurts to put out a FOIA because you never know what you're going to get. I would definitely do it. I couldn't tell you where you would send it or what department you would contact. Maybe you can reach out to John Greenwald. He'd be able to tell you that. Oh, that's okay, Anjali. Don't worry about it. Probably. Okay. Yeah. So in a nutshell, that is the press conference. And like I said, I don't think a lot of those, the anomalies that Avi Loeb listed were addressed. So I think that's a missed opportunity because obviously over this month and a half, they've seen everything that Avi Loeb has said. He's been on all these news networks talking about the different anomalies and why he's even giving the consideration that this is alien tech. And it was a perfect opportunity for them to take those 12 anomalies and build their presentation around that and explain those away. So you can kind of clear the air. And but they left us more confused than ever because you didn't address those things when you had our attention to do it. Right? Just sad. Missed opportunity, guys. And I'm waiting to see if you have any more comments here, guys, because I know it's a lot of you out there. If you have anything that you want to bring up here or say on the screen, let me, I'll give you some time here to go ahead and do that. I like that. Carson Paramar. That would be NASA Department of Malarkey. That's funny. I like that. Yeah, they deny FOIA all the time, but still put it in, because you never know what you'll get. Maybe you'll get a denial, but maybe you'll get, something that you weren't expecting. I really just think that definitely missed opportunity. We didn't come in thinking it was space aliens. I think most people were okay with it being a comet. I'm glad they didn't sort of attack Avi Loeb on this anyway. They should have addressed, though, his anomalies, but I'm glad they didn't come with the space aliens are ridiculous. It's ridiculous to even think that, because even they have admitted that there's likely life out there in one of these vast galaxies, right? And we talked earlier in the show about, space junk, essentially space junk or satellites. And, a couple things we point to is like Voyager 1, Voyager 2 that were sent out 50 years ago that are traveling outside into interstellar space that will eventually, maybe a million years down the line, reach some other place, and it'll be their 3i Atlas, right? Their incoming thing that is a comet or isn't a comet, right? They'll have that discussion. What is this thing coming into our solar system, coming from interstellar space? It'll be that same conversation over in some other galaxy, right? So why couldn't it be reversed? And the whole thing I wanted to see was, would NASA be open-minded enough to, the perspective that not everything we see incoming should just automatically be considered to be something natural or common, because even if it isn't now, at some point down the line, there's bound to be something that's incoming, right? And we already know what we're dealing with here on the planet. We already know that there's weird things here. So even putting that aside, if most scientists, all scientists believe that there is likely life somewhere way out there, you have to imagine at some point in time, you may expect something to be incoming. So that's all Avi Loeb was trying to say. I feel like he's been attacked for that. Just keep your mind open. And it didn't seem, when that question was presented to the NASA representatives, they didn't really answer it in a way that made me feel like they would even take that into consideration, right? The question was asked and they're kind of looking around at each other like, who's going to answer this one? But we know they've caught all sort of things on video. So with that being said, Tony D is asking, what did you think about their answer to the second guy's question about him asking? Yeah. And I just actually addressed that. I thought, yeah, definitely. They looked around at each other, seemed pretty weird, seemed pretty awkward. Like, this shouldn't even be part of the conversation, but it's like, this is, and someone said this earlier, this is what lets you know that even if it ever is something outside of something natural, they're not going to say anything. They wouldn't even acknowledge, or entertain the question about, it potentially at some point being a spacecraft. So, sad to say, I don't know, I don't know what we do with that. What do? We don't, do we just lean on amateur astronomers to get the answers now? Do we take this stuff into our own hands? Do we stop sending all the money over to NASA and maybe fund some other groups that are really interested in getting the answers and getting to the truth? JSCO says head should roll. Yeah, man. Agreed, Andrew. That image is so good, I can't imagine them not showing something better. Yeah. True fact. True fact. It just amazes me that you could get that with this camera, with this telescope, backyard telescope. Look it up. Look it up online. Celestron. It's Celestron. Let's see. I have the list. Celestron Edge HD 800. This telescope took this image, but we were shown absolutely nothing from NASA today. And I can't get over that. And I think that's how we should walk away from this. This should tell you right here. So forget everything else, what they answered, what they didn't answer, what they said, what they didn't say. If they weren't able to bring something as good as this or better to the table, then you have to say something is wrong. Something is wrong, right? Or something is not being said. Something is being hidden just based on this alone. There's no way in the world that we should be seeing something like this and not getting that from NASA. Thank you. Let me go ahead and get this here. Luscious Jules is very insulting. It's depressing too, because that means, you know, people like to say, oh, that's a conspiracy. You know, it's not really like that. But then you have moments like this where you can clearly show that the result should have been different. And I think everyone can agree on that, whether you're on the side of it being something not natural or something natural. I think you can walk away from this and at least say that we should have been shown something better. I think you could walk away and say that. Regardless of who you are, Hillbilly Herb, yep, they had no business putting on a press conference without something at least as equivalent. Stargazer, NASA's like the person you always wanted to marry, but it just didn't work out. And you have to pick up the pieces and move on. And see that's the problem, right? Because then it goes back, okay, NASA was founded during the space race, and there's this whole stigma in conspiracy behind if they said they did, if they did what they said or not. They were kind of caught in a few situations where you had to question what they have actually done. And here's the big thing, right? They supposedly landed on the moon back in the 60s, 69, right? But then you have Artemis 2 now, and they came out and said something like they lost the ability to go to the moon. They lost the knowledge on how to get to the moon. A lot of just fishy stuff. This is a lot of fishy stuff when it comes to NASA. And I know somebody that works there, and they say no, we did it. And I there's evidence that can speak to the opposite, I think. Tony D, what's the cost of one of those telescopes? Let's look it up. Why not? We're here. Let's look it up. Celestron HD. So you can go ahead and get one of these and get an image of 3i Atlas. Let me see. It shows you can get this Celestron Edge HD 800 8-inch optical assembly for $1,700. You can get it with the stand from Celestron.com, just as you saw in the picture, for about $3,600. So a little under $4,000, which means a $4,000 telescope was able to take this image, but the high-rise orbiter, how many millions and millions of dollars did it take for us to send it there in the first place? And then for it to not really result in anything when it came to this, right? $4,000 telescope versus multi-million-dollar telescope in a high-rise, and we got absolutely nothing. Let's see, what else do we have here? Yeah, Kurt M. So a $4,000 telescope outdid NASA. It would appear to be that. There's no conspiracy there. Those are just facts. Those are just facts. What does Ricky Ricardo say? NASA, you got some splaining to do. You got some splaining to do. I want to like NASA. Stargazer says, I want to like NASA, but they make it hard to have a good relationship. That's true. If they were just as transparent as they act like they are, right, then we'd be okay. But there's just too many instances where they're not showing, you know, they're not showing that they're being transparent. Just because you have a live feed for Mars, you have a live feed for the space station, it's still a delayed feed for one, and then for two, you end up cutting it off at the weirdest times, or it has an issue at the weirdest times, right? Let's see. What else we have? All else evidence and knowledge. Let's see here. Okay. Andrew says, yeah, I wonder how much the bill for that press conference is going to be, right? Let's see. Says, come on, Rob G. They did spend $100,000 looking for UFOs. Yeah. NASA splaining needs to be a word. I agree. That was a bunch of NASA splaining. And they did that on the last press conference, right? The one with Arrow. It was just gross. It just felt gross, right? Because it was like you're not saying anything, right? At the end of the day, you're saying a bunch of stuff, word salad, but what does it really mean? What are you really saying? We don't need to hear how you're excited to look into stuff and you're excited, you know, that for X, Y, and Z. We're coming here to see pictures of 3i Atlas, and you did not deliver. Stargazer says, defund NASA for real. And I've never said defund anything, but NASA is a waste of taxpayer dollars. Costs us $1 million to take 1 pound of supplies to the space station. Also, let's not forget, and I don't think we fund SETI, but that's the same thing, right? The search for extraterrestrial intelligence, listening for radio signals, and they may not be using radio signals, right? So what are we really doing there? Mateo C-Tech, NASA equals never a straight answer. No alien seen anywhere. Not a space agency. Love it. Love it. Shout out Mateo, my guy, man. Thanks for coming in, buddy. Luscious Jules has gotten very old. This is true. This is true. Hillbilly Herb, word salad, hold the dressing. Skip to Malou. I like they all had blue except the man to the left, show costumes, but they did not look nice. He looked so angry. Yeah. And to make sure, Luscious Jules, and to make sure to gesture and point around at other people on the panel like you were actually friends and coworkers. I just, there's no reason. And like I said, at the end of the day, I think we were all on the side once again that this was going to be a comet. And it was just like we wanted to see this amazing object, right? Who's ever had a chance to see a comet that close. That's just pretty 29 million miles is, I guess, somewhat close, at least close enough to get an image. I think it's definitely further away from Earth, and we were able to get an image like this. And it was just the expectation, and I think they probably, and here's the thing, they're leaving room for us to say they probably have better images, because they probably do, because the camera obviously is better, or the camera is better than what this telescope can do, period. It has to be. There's no way that this telescope that was used to get this is better than the camera they have on this orbiter. There's just no way. So it just leaves the room to say that they have to have better images that they're not showing, right? And from their end, if that's not true, if they showed the best images they have, they're not doing a good job of closing the gap to leave, so there isn't room left for conspiracy to grow. Because we walked away from this, and I can't wait to see what Avi Loeb says. I can't wait to see what his answer to this is. I can't, there were a lot of people kind of going against what his theories and stuff, and I just want to see now what everybody says now that NASA has kind of come to the table. Let's see. Tony D, they should have a competition on who takes the best image. NASA would come in last. I mean, yeah, that's true. Based on what we've seen, yes, that's true. And there's going to be more opportunities for images. So maybe later on NASA comes through, because technically right now it's visible in the sky, which is how the amateur astronomer was able to capture the image with that celestron. So there's other people, other amateur astronomers that are also imaging this thing. And I would imagine NASA is as well imaging this thing. And they should be able to come to the table at some point here before, by March, because it passes Jupiter. And supposedly there's the Juno spacecraft that's orbiting Jupiter. So they once again have an opportunity to come to the table with a better image. So there's still time. Once again, this should have been just a press release and not a press conference, and then save the press conference for later when you actually get a great image. There's still opportunity. There's still, 4 more months before it begins to leave the solar system, that they have opportunity to get pictures, more images. So hopefully they come to the table with something else. I know I'm probably shouldn't be giving them that benefit of the doubt, but it's true. They should be able to do it, and hopefully they do. All right, Anjali, take care. Thank you for great chat. Ciao for now. Lil Camp 51 says it's like our MUFON. Other countries are so much more ahead and transparent on this topic, right? France has Gaipan, which is their federal MUFON, way more proof than most. Yep, Stargazer, I agree. I bet Avi will say something soon. I'm going to be looking out for that. Carrie Doyle, where are the images from that telescope they have in Arizona? That one is huge. Yep, we were just talking about that the other night. C-Tech Mateo saying December 19th, it'll be the closest to Earth, at 170 million miles away. With the 18 million miles that the ESA Mars orbiter got, should have yielded epic images. Yeah. And that's what, and our camera on the high rise is supposed to be better than the one the European Space Agency has. So our camera should have, at 29, if this Celestron is capturing this image that we're looking at right now at more than 170 million miles away, then the camera on the orbiter, on the high-rise camera at 29 million miles away, 30 million miles, we should have had way better image. And obviously with the Celestron, it has to look through the atmosphere, and they have to stack the images. They have the exposure time because it's the atmosphere kind of blurs your vision of what you're looking at. So they kind of have to do this thing with the exposures where they stack the images in order to get a clear image like this. And you would think something that's in space, which doesn't have to look through any atmosphere, is going to capture chef's kiss sort of image, and it just didn't. Let's see. See what else you guys have out here. Anything else? No, that's about it. So yeah, I think we had the show. I think we had a great show, right? Maybe not the press conference, but I think the communication that we've had here in the chat and the conversation that we had around this was awesome. I think it puts it all into perspective. The letdown kind of that we have here, we all feel the same, and it's regardless of what side of this conversation you were on. We definitely all feel the same. We all feel like we're walking away from this with less than we should have received, or especially with the time that elapsed, because it makes it suspicious that over the last 50 days or whatnot, that you couldn't have something better put together. That when you did, have the press conference, you didn't on your own proactively address the things that everybody was asking and talking about on social media that you were totally aware of. None of that was put into your presentation. It had to be asked after the fact from people that were calling in, and thank God they at least had that portion, because if they didn't have the call-in piece, then we would have really been left with nothing. At least they had a couple of the questions that we wanted posed. But yeah, just totally disappointed. Hopefully in the future we get better images from them. We're going to go ahead and get up out of here, though, guys. It has been awesome. I really appreciate you guys. If you wouldn't mind, if you're watching from X, I don't know if you're ever on YouTube, but we'd appreciate you coming over to our YouTube channel and hitting the subscribe. We definitely have a bunch of awesome shows that we do over there 7 days a week. We have something going on here at Spaced Out Radio. We have some new things on the horizon that we're working on too. Also, you can find me over at the Social Dig. You can find me right here on X as well under the handle at Mr. Rob G, the same way you see spelled on the screen. Also, you can find me on YouTube under the same handle at Mr. Rob G. So I'd appreciate you guys coming and hanging out, hitting that like button. Let's get the likes up as high as we can for the algorithm. And I'll be seeing you guys shortly. So with that being said, much love to everybody out there. Thank you so much for coming in and hanging out with us for this presentation. We are getting out of here. And this is how we do it. We want retribution. This is how we shut out our show each and every time. I'll see you guys this weekend on the After Hours Radio Show. Much love. Take care. Talk soon. Oh, also, we have the Age of Disclosure review show this Sunday on Spaced Out Radio, 7 p.m. Pacific. Age of Disclosure documentary comes out this Friday on Amazon. Supposed to be a big deal. So if you watch it, I would recommend to watch it. That way we can have the conversation on Sunday as we go ahead and review that documentary. Until then, rip out of here, guys. Much love. Take care of each other. Till next time. Peace.
Cause we want retribution. Oh yeah, we want retribution. Oh yeah, we want retribution.